Hi, this is Francis from Easel. Today we're going to be doing a video on how to calculate cut settings. Um, by default, Easel will provide you, if you're using a custom bit and material pairing that has not already been tested, Easel will provide you with kind of generic cut settings, which you can change in the manual settings. But typically, we recommend if you're not sure what cut settings to use or uh, anything like that, you can look at the manufacturer of the bits recommendations, or you can go through and calculate them yourself. And so there are a couple of kind of things we're going to cover and concepts we're going to talk about. So let me move over here. So the first thing to kind of talk about is a couple of terms. The first one is feed rate, and that's the linear speed at which the cutting tool or workpiece travels while the spindle is spinning. So as the bit moves across your material and is carving, that's the feed rate, and that's typically measured in inches per minute. And then depth per pass, which is also sometimes referred to as depth per cut, is how deep your bit goes into the material every time it starts a new tool path. So essentially, depth per pass is if you've got a 1-inch thick piece of material that you're cutting through and your depth per pass is set to a quarter of an inch, it's going to do 4 depth per passes. One at a quarter of an inch, and then it'll go down another quarter of an inch and do another pass at half an inch, and then down again and do a pass at 3/4 of an inch. Spindle speed, which is typically measured in RPM, is how fast the cutting tool is spinning. Chip load is the amount of material removed by each flute or tooth on the bit. And then plunge rate is the speed at which the CNC tool or a bit moves vertically into the material. And this is also typically measured by inches per minute. And so a lot of this information can be found with your manufacturer and or your bit manufacturer, and I'm going to show 2 instances of that. Both are with a bit seller called Amana Tools. If I click onto here, I can see one bit that I'm looking at, which is this carbide tit straight plunge single flute high production bit. I can see a couple pieces of information here, but if I'm looking for feeds and speeds, I can click onto here. And if I click on to download this PDF, this is the bit number right here at the top, and I can see a couple pieces of information. I can see the diameter, the shank, the number of flutes, and then the inches per minute, which would be the feed rate, and then the chip load per tooth. And we can see that for the most part, the inches per minute stays the same, except when doing kind of a softer material like MDF, and then it goes back to plywood. So we can find our inches per minute, but we might need to calculate our plunge rate. And we can also see here that the CNC operating spindle speed is 18,000 RPMs. And not everybody's machine goes up to 18,000 RPMs. So we'll talk about how to calculate that in just a moment. But again, typically the first thing I recommend is just checking your bit manufacturer's website, because they'll typically have speed and feed rate information, and you can at least find the information you need to calculate it for yourself from their information. And so we've got another bit here, and I've got 2 bits that we're going to talk about today, and this is another one from Amana. It's the 0-point V-groove 45-degree half-inch diameter bit. We've got a feeds and speeds here. We can also download this PDF, and we can see again, operating speed 18,000 RPMs, and then it gives us inches per minute for different materials. And then it also gives us down here at the bottom simple machine in calculations for certain things. So like feed rate, inches per minute, and then chip load. So we're going to talk about, I think, the 2 most important calculations here, which are feed rate calculation and the plunge rate calculation. And if you look at both of these calculations, they're essentially multiplying the same 3 pieces of information: the spindle speed, the chip load, and the number of flutes. So if we were to multiply these all together, it would equal the same thing for each. So what's really the difference? Typically, the plunge rate is between 50 and 30 50% of the feed rate, and that really depends on how aggressive you want to be. 50% would be the more aggressive side, and 30% would be the more conservative, less aggressive side. So that's something to keep in mind. In this case, I've done the calculations for both, so we can take a look at that. But essentially, you would just take the chip load for the feed rate, multiply that by either 0.5 or 0.3, and then use that number for the chip load in the plunge rate, and that should give you the information that you need. And so let's go ahead and take a look at some calculations. So I'm going to do the V-bit we demonstrated first. I've got its bit information here, and then at 8,000 RPMs, we can check our feed rate here, and we've got a chip load of 0.0024, flutes of 2 flutes, and then an RPM of 18,000. And that gives us a feed rate of 86.4 inches per minute. So that's a good feed rate to start at. You may want to be a little more conservative depending on how hard your material is. So that's something to keep in mind. But this is a good starting point for just kind of running your machine. And then we've calculated our plunge rate at 30% to 50%. And we can see that here. Plunge chip load, we've taken the chip load for the feed rate, multiplied it by 0.5, so we get 0.0012, and then the plunge rate is just 0.0012 times 2 times 18,000 to give us 43 inches per minute. If we wanted to be a little more conservative, we could multiply that by 0.3 and get a plunge rate of 0.00072, or chip load, and then multiply that in the same way, and we get 25.92 inches per minute. And then one thing to kind of mention is not always, especially with some CNCs, does your spindle go up to 18,000 RPM. So if that is the case, you can exchange 18,000 RPM for your feed rate of, let's say, 16,000 RPM or 12,000 RPM, whichever one, and then redo those calculations using the same chip load and flutes, and you'll get cut settings for your machine. And that's something to keep in mind. And then similarly, we've got our straight plunge bit here. I've done the calculations at 18,000 RPMs, and we can see the feed rate of 0.0017 times 1 times 18,000 equals 30.6 inches per minute. And then at a 50% chip load on the plunge rate, we get 15.3, and a 30% chip load, we get 9.18. And then if we move this over, at 16,000 RPMs, those numbers go down accordingly. So that's essentially how you calculate feed rate. And again, you want to utilize the information that the bit manufacturer has, and then the information with the calculations. The calculations can be found in our Support Center article. So I'll link that below. We referenced it earlier. I'll show it one more time here to look at these calculations. One other thing to mention is you can calculate chip load. You can do that by taking the feed rate and dividing it by the spindle speed and the number of flutes. So that's something to keep in mind. If you're missing a step or have a bit that's not necessarily made by a manufacturer, you can still kind of run through and try and calculate that out for yourself. Anything to do with cut settings, however, I will mention, is very specific to your machine. And it's really important that when you create cut settings for yourself, run a test carve. See how it's going to work. Make sure things are working well. If your chip load is too small, you might see burning. If your chip load is too large, you might see your bit breaking or something like that. So it's really important to test your cut settings as you're once they've been created. Just test them out, see what feels right. You can also adjust cut settings depending on the hardness of your material and those things. One more thing to mention is depth per pass. Typically, my recommendation for calculating that is starting with half the cutting diameter of your bit. So if you're using a 1/4 inch bit, start with a depth per pass of 1/8. If you're using a 1/16 inch bit, start with a depth per pass of 1/32. and just see how that feels and how that works for you. If you find that it's not working well, always reduce your depth per pass. I never recommend, or typically if you're struggling with depth per pass or something that's a bit's breaking, try reducing your depth per pass. That should typically help with strain on the bit. And that's just a little bit more about calculating cut settings. Again, I'll link this article below. And certainly if you have any questions, comment on the YouTube video. We're certainly happy to help. Have a wonderful day. Bye.
To learn more, head over to Easel.com.